All right, Precalculus, this is it. Our very final lesson of the year. Lesson 8.7, problem solving with 3D vectors. So exciting. Learn this and you're done. And this lesson isn't even all that challenging, so that's good. So what are we going to do here? Our lesson objectives. We're going to create a set of parametric equations to represent motion along a linear path in 3D space, use a system to solve the problems. We're going to calculate the measure of the angle in 3D vectors using the dot product. So you've seen that language before. How is it going to change? Very simply, not by much, you'll see. We're going to decide if two 3D vectors are parallel, perpendicular, or neither. Kind of. We're not really going to decide that, but we are going to refer to it in one example. So let's move on. All right, so let's get started. I'm not going to do the warm-up. You guys can do that on your own. Check the answer key. It's just going back to the basics of finding an angle between two vectors. So we're going to move on to three-dimensional space. So far you've studied everything in two-dimensional space, right? So this is a review of what things look like with your x-axis and your y-axis. So what happens, and we have this vector that represents, moving horizontally right 3 and then up 4. So what happens when we add a third dimension? So you can see here we're going to add our third dimension. So it's going to be our x-axis coming out here, our y-axis here, and then we're going to add this third dimension up here. So we drew this box to try to help you see, this is the bottom of the box here, this is the top, and we have right, left, front, back, so it's a little bit geometric there. So now our ordered pairs are going to be not ordered pairs, they're going to be ordered triples. So we have an x-coordinate, a y-coordinate, and a z-coordinate. You can see here in this diagram, we're going from the origin out to this point here, and it says, well, what would the magnitude be of OP if this is P right here, right? So we're trying to find from the origin to this point X, Y, Z. So in order to find the magnitude, remember this absolute value symbol means magnitude. Remember we took the distance, right? Use the distance formula. We did our horizontal difference, added it to our vertical distance. It was just the Pythagorean theorem. And now we're going to do the exact same thing, except we're going to have our Z component in there as well. So you take the difference of your x's, square it, the difference of your y's, square it, the difference of your z's, square it, add them all up, take the square root, and that will be your magnitude. So I would say pause here and just try these on your own and see how it goes. Like here, your vector from the origin to point A, well, that's going from 0 to -3, so that's down 3. From 0 to 1. Because remember, O is your origin, that's 0, 0, 0. So 0 to 1, so that's 1, and 0 to 2. So that would be what your answer would be for OA. So I would just pause, try these on your own, and then you can come back and see if you got the right answer. All right, so check it out. A to B here, let's look at that. So vector A to B, so we're going from A, -3 to +1, so that would be to the right 4 units. From 1 down to -1, so that would be down 2 units. And then from 2 up to 3, that would be up 1 unit. So you should have gotten your vector to be 4, -2, 1. And then for our magnitude, right, well, we're taking this vector right here from A to B, and we're just squaring each of those values. So you should have gotten square root of 21 units per second. Just square root of 21 because we didn't give you any units. And then here we're taking OB, vector OB, and adding it to twice vector OC. So it's literally like algebra. You would guess 1 plus 2 times 4, which is how we got 9. -1 plus 2 times -1, which is how we got -3. And 3 plus 2 times 2 is how we got 7. And that's it. All right, moving on. It says calculating the angle between 3D vectors. So recall from previous lessons that the angle between two vectors A and B can be found using the dot product, right? And two vectors are perpendicular if the dot product is 0. So if these two things are 0, and two vectors are parallel if one is a scalar multiple of the other. And we are going to talk about that right now because example 2 is about these two vectors A and B being parallel to each other. So it says find P and Q given that vectors A equals 2, -1P and B equals Q 2, -3. and given that they are parallel to each other. So if they are parallel, they must be scalar multiples of one another. So there are two ways you can do this. You can either kind of say to yourself, okay, 2 negative 1p is going to equal some number multiplied by q to negative 3. Or you can say some number multiplied by 2, negative 1, and p is going to give you q to negative 3. Either way, it doesn't matter. You're going to get the same answer for p and q. So let's try it. So our key is this middle number, right? It says negative 1 equals 2k, therefore k equals negative 1/2. So basically now I know that k is equal to 1/2. That's my scalar multiple, sorry, negative 1/2. So I'm going to say here, let's get a different color, 2 equals negative 1/2 times q. So what is q going to equal? It's going to equal negative 4. Or let's try this lovely yellow color and see what happens. We can say p equals negative 1/2 times negative 3. So what is p going to equal? It's going to equal 3/2. So it looks to me from this first example that p equals 3/2 and q equals negative 4, and then that would make vector A be parallel to vector B. So let's see if we can do that same thing for our second example. We could also say, okay, we can multiply negative 1 times k, and that should give us 2. Therefore, k would equal negative 2. Okay, so I'm going to replace k with negative 2. Now I'm going to say negative 2 times 2 is going to equal q. So q equals negative 4. Well, that's the exact same answer I got before. So yes, so far what I said was correct. And then I have here negative 2p equals negative 3. So what is p going to equal? It's going to equal 3/2. So once again, either choose this first way or the second way. Either way is fine. You're going to get the same answers in order to get those two vectors to be parallel to each other. Moving on to example 3, it says if A, which is 4, 2, negative 1, and B, which is negative 1, 5, 2, and C, which is 3, negative 3C, are vertices of triangle ABC, and angle ABC is a right angle, find the possible values of C. So this is very important, angle ABC, right? That means that you have A out here, B right here, and C right here. So in order to find the angle ABC, you have to find vectors BA and vectors BC. And if these two vectors are going to create a right angle, you know when you find their dot product, it should equal 0. So first though, before I do that, I need to find the two vectors. So you can pause and do it on your own, or you can follow along here with me. It's totally up to you. But I'm going to go from B to A, so that's going to be right 5 units. Then I'm going to go from, the x coordinate, the y coordinate now, 5 to 2, which is negative 3, and then 2 to negative 1, which is also negative 3. I'm going to go from B to C. So from negative 1 to 3, I went up 4, or right 4, I guess. From 5 to negative 3, that's going to be negative 8. And from 2 to C, oh shoot, how do we do that? Well, if you think of it mathematically, we're taking this number on the right and subtracting this one. So 3 minus negative 1 gives us a 4. Negative 3 minus 5 gives us negative 8. So it's going to be C minus 2 here. Okay, now that we have our two vectors, we're going to find their dot product. And if you recall from a two-dimensional vector with just x and y, all you had to do was multiply their x's to each other, add it to the y's, and then they equaled 0. So now we're going to do the same thing, except we're going to not only multiply the x's and the y's to each other, but we're also going to multiply the z's, and then we're going to set it equal to 0 and solve. So you can pause and do it on your own, or you can follow along with me. So I'm going to do 5 times 4 plus negative 3 times negative 8 plus negative 3 times C minus 2 and all of that together has to equal 0. So I get 20 plus 24 minus 3c plus 6 equals 0. So once I simplify that, what do I get? 3c equals 50. So there's only one possible solution instead of values. There's only a value. So it looks like c is just equal to 50 over 3. Now we are on problem 4. So it's just kind of a basic example to show you that adding z doesn't really change any of your process. So it's all the same, except now instead of having an x and a y, we have our third dimension of z. So it says a particle starts at point 2, negative 3, 1, and after 1 second passes through point 4, 1, negative 2. Write a vector equation that describes the path of this particle from 0 to 5 seconds. Well, this was only what happens after 1 second. We want our parameter to be from 0 to 5, so we're still just going to keep that. And then we have 3 components, so our vector equation is x, y, z such that we need our starting point, or initial position, which is 2, negative 3, 1. And then we need to figure out what our velocity vector is and multiply that by time. So what is our velocity vector? Well, we know after 1 second it went from this first point to this second point. So I got from 2 to 4, so that was positive 2 units. I went from negative 3 to 1, so that was up 4 units. And then I went from 1 to negative 2, so that was negative 3 units. So this is our vector equation, which represents this path. What would the position be after 3 seconds? Well, hopefully you're just saying to yourself, that's easy. I'm just going to make my time appear equal to 3. So x would equal 2 plus 2 times 3. Y would equal negative 3 plus 4 times 3. And z would equal 1 minus 3 times 3. So what do we get there? We get an 8. We get a 9. And we get a negative 8. So you could say 8, 9, negative 8, and that is where the vector would be, or sorry, but that was where the particle would be after 3 seconds. If you're going to calculate the speed of the particle, remember all you do for the speed is just take the square root of the difference in your x's and your y's and your z's. Or in this case, we're just going to take our velocity vector. So it's going to be 2 squared plus 4 squared plus negative 3 squared. So that's 4 plus 16 plus 9. So that is just simply the square root of 29. We didn't give you units again, but typically if we did, you would just do your units per second. Nice. Let's do our last example. Okay, for this last example, I think you should be able to do the whole thing on your own. Actually, letter C will be a little bit tricky, but you could still try it on your own, and then you could check it with the answer key. So the speed, we already know how to do that, especially if we give you the vector, looking at the velocity vector to get that answer. Position, so determine the angle. So again, you know how to do that. Instead of just having your x's and your y's, you're going to add your z's in there. So you can try that and see if you got the right answer. So try it, and then letter C is definitely going to be the hardest. So if you want to find out when they collide, that's when you have your system of equations. So I'm going to tell you what you need to do strategically, and then I want you to try it on your own. So system of equations, but your system of equations is going to have an x and a y and a z equals a number, and it's going to be some coefficients in front of there, right? So you're going to have to eliminate your z's or your y's, your x's, and then you're going to have a system of 2 equations, and then you're going to have to eliminate again. So it's just going to take a little more time, but it's going to take way too long if I explain everything on a video. So try it on your own, and then you can compare your answers to the answer key and see how you do. And then you can ask your teacher if you have specific questions. All right, good luck. Happy last homework of the year, and see you soon.